Okay, so this is just a quick refresher on matrix multiplication, just in case you haven't seen this in a while. So recall that a matrix, which is just some grid of numbers, let's say 1, 2, 3, 8, 4, 4, right? So a matrix has a certain number of rows and a certain number of columns. So in this case, I have a 2 by 3 matrix, right? So 2 by 3, because there are 1, 2 rows. So row number 1, row number 2, and I have 1, 2, 3 columns. So it's a 2 by 3 matrix. And in general, if I want to multiply two matrices together, I have to understand the size of these matrices. So if I have matrix A, which is 2 by 3, and matrix B, which is 3 by, 7, right? And so what this looks like is, so matrix A has 1, 2, 3, 1, 2, 3. So matrix A has 2 rows and 3 columns. Matrix B has, oh my goodness, 1, 2, 3, 4, 5, 6, 7 has 7 columns and 3 rows of these 7 columns. Then what's going to happen when I multiply, I have to make sure of 2 things. One, if I want to multiply A times B, I have to make sure that these 2 numbers are the same. So 2 times 3, so these middle numbers. So the columns of A have to be the exact same as the rows of B. And if that's the case, then my final matrix that I'm going to have is going to have the shape of in this case, 2 by 7. So the numbers that are left on the outside, 2 times 7. So this is going to have 2 rows and 7 columns. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Like that. So a 2 by 3 multiplied by a 3 by 7 gives me a 2 by 7 matrix. If I happen to have the case where matrix B actually has 4 rows, so let's say it looked like this, right? Then these 2 numbers in the middle are no longer the same, and I cannot do a multiplication. It just doesn't work. It just does not work. And then let's just do one quick example of what we're going to see most often, which is a matrix applied to a vector. So let's say I have a matrix, let's say I have matrix A. Now, matrix A is going to be, how about 1, 1, -1, 1, like that. And my vector V is going to be, in fact, let's make this more fun. Let's make this 1, 4, 5, and -2. And let's make this 100 and 10, like that. Okay, so A times V. So A is 2 by 2, right? So it has 2 rows and 2 columns. And V has 2 rows and 1 column. So it is a 2 by 1. Great, my middle numbers line up. I can multiply these 2 together. And what I'll get at the end of it is the outside numbers, 2 and 1, a 2 by 1 matrix. I'll just call this W for now. I happen to know that it's going to be a vector, don't worry about that. So let's actually run through the math. So I'll rewrite this over here. Let's erase some things. So matrix A being multiplied by vector V, which as we said was 110, like this. The way that you multiply vectors together is you take this top row and you take it and you turn it sideways and multiply the pieces. So it's 1 and 4 like this, right? And so if I do that, I'm going to get in my top row, I'm going to get 100 times 1 plus 10 times 4. So 100 times 1 plus 10 times 4. Then for my bottom row here, I'm going to take this column, turn it sideways, and multiply it by this vector. So I'm turning it sideways, so that's what, 5 and negative 2. And so 100 times 5, so 100 times 5 plus 10 times negative 2. 10 times negative 2. Okay, and what does that equal? So it's going to equal 100 times 1, that's 100, plus 10 times 4, that's 40. So 100 plus 40 gives me 140. And then 100 times 5, that's 500. 10 times negative 2, that's negative 20. So 500 plus negative 20, or 500 minus 20, is going to give us 480. And so our final answer then is that vector v being so a times v is going to give us 140 and 480 as our vector w. And that is how we multiply vectors and matrices.